In this video, I'm going to introduce the concept of parametric equations. So far in your mathematical careers, you have been exposed to functions such as y is equal to some function of x. An example of this would be, a quadratic equation such as y equals x squared plus 2. In this particular case, we would say that x is the independent variable. In other words, x can vary. It can take on any values we want it to within certain constraints. And y is the dependent variable. Y varies depending on what x is. So x is the independent variable. It can take on any value, and y depends on what x is. However, in more advanced mathematical modeling, it's not at all uncommon for x and y to both be dependent on a third variable, which we call the parameter. And quite often we use t to represent the parameter because t, in many mathematical modeling examples, represents time. So think of t as time. And so in this definition of parametric equations right here, what this is telling us is that x is a function of t and y is a function of t. And once again, t is called the parameter. And we can sketch the graph of a pair of parametric equations. And that's what we're going to be doing here in a moment. And the actual graph is called a parametric curve. So our first objective is to learn how to graph parametric equations. So let's do a few examples of that. So here we have parametric equations. X is a function of t, and the actual rule of that function is t minus 1. Y is a function of t, and the rule of that function is 2t plus 4. So what this means is we can create a table of values just like we would if we were graphing something in the form of y equals f of x, except in this time we have the t column, the x of t column, and the y of t column. In essence, we have two independent variables, x and y. Both are dependent on t, the parameter. So it's fairly straightforward. We want to graph this over the interval from -3 to 2. So I've taken the values from -3 to 2. Now, you don't need to use integers. You could use fractions. You could use rational numbers of some kind, like a square root. In most cases, especially now, this is going to be easier to just use some integers. But you may have some cases where if you have a sine or cosine function that you're going to want to use different types of values of t. All right, so to figure out when t is equal to -3, we want to find out what x of t is. We simply substitute that into our function. So when t is -3, we get -3 minus 1 is -4. And so when when t is equal to -3, we see that y is going to be -3 times 2 is -6 plus 4 is -2. So there's nothing really new here. We're just evaluating functions at values of t and creating a table of values. So we go through and do that for all of the values of t within our interval from -3 to 2. And so we get these sets of ordered pairs. So what we essentially have here now is an ordered pair. We have an x and a y value, an x and a y value, an x and a y value. So all of these are our ordered pairs in the Cartesian coordinate system. And so we want to plot those. And so the first point, -4, -2, my graphs are always a little bit sloppy, but that would be this point right here. And so that corresponds to when t is equal to -3, so I labeled that. Our next point, -3, 0, is right here, and that corresponds to when t is equal to -2. And then we have -2, 2. We have -1, 4. we have 0, 6, and 1, 8. And so I labeled the values of t that correspond to those. Now, one last thing, and so this basically is the graph of the parametric curve. Now, two things to note. The actual curve starts at t equals -3 and ends at t equals 2, okay? Now, the little arrows that you see are not the arrows for the line saying that it goes on infinitely far. The actual line starts right there and ends right there. What the arrows mean are direction. So the one thing that is unique about a parametric curve is it has direction. So again, if you think of t as being time, and you think of time as progressing. So if we're going, and I know a negative time doesn't make sense, but if you think of a -3 as being, okay, well, this is what was happening 3 seconds in the past, 2 seconds in the past, 1 second in the past, 0 is what's happening right now, 1 is t 1 second in the future, 2 is 2 seconds in the future. If you think of it that way, we can kind of make some sense out of some negative values for time. And so what's happened is the parametric curve is sketched out along the line starting when t is equal to -3, okay, starting when t is equal to -3 and ending when t is equal to 2. So there is direction to it, and that direction is along that line in that direction. And that's what these little arrows mean. Okay, so it's really important when you sketch a parametric curve that you sketch the direction of the curve. Just put a little arrow along the curve that shows the direction. And again, if you think of it as time and think of time as progressing along, then how is this curve being sketched out as time progresses? And it's going in one direction and one direction only. All right, next example. Sketch the curves described by, we have x sub t is equal to t squared minus 3, and y sub t is 2t plus 1. So once again, t is the parameter. It's acting as an independent variable. X is dependent on t, and y is dependent on t. And we're interested in sketching the parametric curve between t equals -2 and t equals +3. So the process is exactly the same in the last problem. We're going to make a little table of values, and I am going to put in the values of t between -2 and 3 as integers, and then we're going to determine the values of x sub t and y sub t. And so we simply do that by taking x sub t, substituting in -2. -2 squared is 4, minus 3 is 1. And y sub -2, so when we evaluate function y at t equals -2, we get -4 plus 1 is -3. And so we've created a set of ordered pairs once we do this for all of the values of t. And what we want to do is then plot these ordered pairs, which I did here. Here's corresponds, we're starting right here. That's our starting point. That is at t equals -2. Our ending point is way up here at 6, 7. Now, clearly, if you just did the endpoints, you wouldn't have any idea as to what this graph looks like. Maybe you would just draw a straight line between those 2 points. So as we enter more and more of these values, I say, oh, well, there's my second point that corresponds to t equals -1. Clearly, this isn't going to be a straight line. And we are going over to t equals 0. And now we start to turn back. At t equals 1, we're going to -2, 3. And then at t equals 2, we have 1, 5, and then back up to t equals 3. The question is, what does this graph look like? And so you kind of have to kind of fill in the dots a little bit and sometimes take a little bit of an educated guess. And once we learn how to eliminate the parameter, you're going to see very easily exactly what this graph is going to look like. But this is essentially a parabola. It is a sideways parabola that is opening up to the right. And so we want to draw a line between these points. And then, of course, the last thing that we want to do after we draw the line is we want to put our little arrows. This shows the direction that we are tracing along on the parametric curve. Okay, so we're going from -2 to 3 in that direction. Another example. And so you can see ahead of time, this is going to be a circle, but you don't always know that. But you can tell sometimes by looking at the parametric curves. So in this particular case, x sub t is a function of cosine, 4 times the cosine of the parameter t. And y sub t is 4 times the sine of t. Now, just as a little bit of clue, when you have sines and cosines, chances are it might be something like an ellipse or a hyperbola or a circle or even a parabola and any of the conic sections. And so when the coefficients of sine and cosine are the same, you're looking at some type of a circle. So that's just kind of a little clue, but we're going to get to that in the next video, actually. So I want to make a table of values, and I want to go from 0 to 2 pi. And so I'm going to take some values that I know off the top of my head from trigonometry. First, I chose starting at 0, of course. So here we have starting at 0. Whoops. Starting at 0. And evaluating x sub t. So you have x sub 0 is 4 times the cosine of 0. Well, the cosine of 0 is 1, and 4 times 1 is 4. Y sub t, we have 4 times the sine of 0. The sine of 0 is 0 times 4 is 0. So we have our first ordered pair, 4, 0. I like to do the quadrantal angles. Sometimes I skip around when I'm doing these. So I did the 4 quadrantal angles because we should know the sines and cosines of those. And so the quadrantal angles are here. There's pi. Here's pi over 2. And here's 3 pi over 2. And so we just simply evaluate the sine and cosine of those functions, multiply them by 4. And so that doesn't tell me a lot, but it kind of, the fact that each of these distances are equal suggests to me that it's probably going to be a circle. But we still need some more information. So what I chose for my next points in between these was the halfway point, splitting each of these quadrants in half, which is pi over 4. And then, of course, we have 3 pi over 4, and then 5 pi over 4, and then 7 pi over 4. And so the sine and the cosine of pi over 4 are all radical 2 over 2, and so we just have to multiply each of those by 4. So 4 and the 2 cancel, we end up with 2 radical 2. So all of the answers are going to be plus or minus 2 radical 2. And so we have these points right here. And the easiest way to determine whether it's plus or minus, again, going back to a little bit of trigonometry, is just knowing what quadrant it's in. In the first quadrant, sine and cosine are both positive. In the second quadrant, sine is positive, cosine is negative. In the third quadrant, they're both negative. And in the fourth quadrant, cosine is positive and sine is negative. And so that's just going back to all students take calculus. All functions are positive. Second quadrant, sine is positive, and it's reciprocal cosecant. Tangent and cotangent are positive. Cosine and secant are positive. So again, we have to remember a little bit of trigonometry. All right, and then of course back to 2 pi at the beginning, which is going to be the same as 0. And so that pretty much gives me enough information based on the nature of these parametric equations and what this graph is looking like. I can take a pretty educated guess and say that this is going to be a circle. So then I just kind of sketch in the circle real nice. And don't forget to draw your arrows, the direction arrows. We are progressing from 0 to 2 pi counterclockwise along the circle. Counterclockwise around the circle. And that is our parametric curve. All right, so that is going to be it for this video. In the next video, we are going to learn how to eliminate a parameter and how to parameterize. All right, have a good one.